The animation that we want to implement in this lecture includes something like this, that we write a text, we move the text, then we do a couple of rotations, and we wipe out some of the part and let the other part become bigger. Let me show it again. So in this lecture, we would want to do such a thing, meaning we write some text, we move the text to the top left corner, we change the color, we do a couple of rotations, then some of the text will be wiped out in an animated form, and obviously one of the parts would get bigger, and you could guess what that name would be. So let's see if we could implement this animation in our manim file, mytest.py. So one of the important things in the manim is moving objects, and these moving objects include everything, meaning what I'm explaining here about moving the text includes actually moving any other object would be done in the exact same way. But the first thing that we would need to do is to tell you what the manim screen would look like. For this reason, I first want to add something to the screen so you would see what I mean by manim screen. I just say number plain, and let me also add some wait, so you would wait for a second. If you don't understand some of its part, it means that I've explained in the previous lectures. But wait simply means that 1 second it would wait after this is implemented. So I press Ctrl S and it would get executed. Now, if we look in here, you see it says Messi is the goat and the number plane would be created. Now, this is, we call this as the manim plane. If we count the squares, we see that we have 14 squares horizontally and 8 squares vertically. We call this 14 by 8 as the manim screen or the manim unit. So manim unit divides the screen into 14 by 8 pixels. If you want to say pixel, generally means picture element. So the elements or the unit of the elements in the manim is 14 horizontally and 8 vertically. In fact, we could even in here say add coordinates. So you could also see that we have put some numbers, so you could see what I mean by that if you already don't know. So in here, if we look, you see we have from -7 to 7 and from -4 to 4. So the vertically is exactly 8 squares, but horizontally, even though it is 14 squares, but we have a bit of a space in here, which right now we don't talk about it. But then I would explain how we could cover this small space in here. So 14 by 8 is called the manim unit. Now that we understand what this is, let us see how we could move this text. If you pay attention, right now, the length of or text that we have written is from almost -2 to 2.5. You see, M is at -2 and T in here is at about 2.5. So if I want to move this to in here, I have to move it 1 square, 2 square, 3, 4, and almost 4.1, 4.2 in the X direction. So what we would say, to move something, we use some method called move to. So I say self.play, or actually say it in this way. Let us say my text is the text that we have, which represents Messi is the goat in the manim. This is just a string. So my text is the object that we want to work with. So we say my text dot move to, and this takes when one argument as an array, or we have to provide 3 arguments in this array for how much you would want to move in the X direction, how much you would want to move in the Y direction, and how much in the Z. Z for now would be equal to 0. So for Y and X, an important factor is that it says how much you want to move something in that direction. It doesn't say exactly it would be moved at that direction. So if I want to move the M to the left corner, to the left side in here, as I said, you would have to move this text about 4.2 units of the manim unit. So we say -4.2, meaning I want 4.2 squares or manim unit to be moved to the left side. Let me just put 0 for the Y, which means I don't want to move it in any vertical direction. So let me also maybe add some weight so you could see it better. So Ctrl S, and let's see how it would be done. So after, it would take a while until it is rendered. And here, if you pay attention, if you look, you see it has been moved. Now you might say I want it to be moved in an animated form, not just jumping. So we have been able, as I said, I will exactly explain how we could move it in any position that we want. But for now, let's say how we could animate it rather than the jump. If you pay attention again, it is jumping. So for animating something, we would say something like this. We say self.play, and then in here we name the text, which is my text dot animate, and then I say move to, actually let me I should have copy pasted this in here, but let me actually write it. So minus 4.2 in the x direction, 0 in the y, and 0 in the z direction. Maybe I could even add a runtime of 2, which means it would take 2 seconds until this moving from the center to the left side is achieved. So let me also comment this line out, or actually let me just remove it. So Control S again, and it takes some time. And after it is finished, actually it's taking a bit more. So now if you pay attention in here, it says, right, the message is the goat, the number plane is drawn here, then it is animated and it is going in the left side. But our goal is to also move it upward as well. Now, if you pay attention in here, T is right now is about here, right? You see, it's about in here in vertically. So you would need to move it 1 complete square, 2 complete square, 3, and also maybe 3 quarters of 1 square. So maybe 3.75 or 7 to be sure is a better number to move upwards. You see, positive would move upwards, negative would move downwards. For this direction, negative would move leftwards and positive rightwards. So let me now press Control S in here, and also you would see if you wanted to move to the left and then up, you should have written another animate method in here. But we want at the same time for this Messi is the goat to move diagonally in the top left corner. So you see we have the number line here, and Messi is the goat would move in this direction in the top left corner. But a better practice would be to do this. Let me actually copy paste to be sure that we exactly move it, because moving is really important in the manim. I would say it is the most important part of the manim is to exactly be able to move, to know how to move things in your screen. So in here, in a seat for the X side, I want to say that since the left side is 7, obviously it is minus 7. So 7 minus my text dot width, meaning whatever is the width of my text, obviously we would see at the beginning in here that half of the text would go in the left side and half of it would go to the right side. The same thing vertically as well. Half of it is higher and half is lower. So I want to say whatever the my text width is, I want to divide it by 2, which means half of it is actually at the left side of my center. Then what I want to do is to subtract it from 7 and add a minus sign, because I want to move it to the left side. So 7, I subtract the half of this width of my text from 7, which is the length of each side of my screen. Then I add the negative side, which means that I want to move it to the left side. And then I would want to do the exact same thing to the y as well. This time I say 7 minus my text dot height divided by 2. And obviously, because I want to move it upwards, I wouldn't add a negative sign in here. So if I save this, what I expect is the same thing that we applied in the previously, but this time I want it to exactly move at the top left corner of this square in here. My goal is that this would be moved in here. So let's see if we have implemented it correctly. So you see it exactly moved in that direction. Actually, it moved upwards after that. Let me see what mistake I have made in here. So we say its height. So it is moved to the left side. Let me see what error we have made. It is moved to the left side, top left corner, but then it actually moves upwards. So I don't know what mistake I'm making in here. So actually, let me see if I've commented this line. So no, I first should comment this line out, and then again, Control S. This time I would expect the exact same thing to be done. Obviously, when we execute the same line twice it would get done. So let's see if we have the same thing in here. So it is moved. No, again, a mistake. Oh, you see, from the y direction, it is not actually 7 squares. We have 4 squares in each side of the y part. So this was the mistake that I made, because as I said, the screen is not a square. It's actually in a rectangle form, which means that we have 4 square in the y direction in here and 4 in here. So I need to add 4 in the y direction and 7 in the x direction. So this time, if I press Control S again, I would expect the exact same thing to be done, so that the text would be moved to the top left corner. So this is the goat, and it is moving to the top left corner, and exactly right. This time we were able to move it exactly. In the next lecture, we are going to go deeper in how to animate things.